Natural polymers. A polymer is a large, long-chain molecule formed by joining together thousands of small monomer molecules. Polymer can be classified into two groups. Number one, natural polymers, and number two, synthetic polymers. Example of natural polymers: DNA, proteins, cellulose, starch, and natural rubber. An example of synthetic polymers: polyethylene, polystyrene, nylon, and polyesters. Proteins. The monomers of proteins are the amino acid. Amino acids are linked together by a condensation polymerization to form various protein polymers. The condensation reaction join together the carboxyl group and amino group, and a molecule of water is eliminated. A peptide linkage is formed. Carbohydrates. Glucose molecule is the monomer of carbohydrates. The molecular formula of glucose is C6H12O6. A condensation reaction joins thousands of glucose molecules to form two types of complex carbohydrate polymers that are starch and cellulose. Two hydroxyl groups from adjacent glucose monomers link up with the elimination of a water molecule. Natural rubber. The monomer unit for natural rubber is isoprene. The IUPAC name is 2-methyl-but-1,3-diene. Diene comes from two double covalent bond in the molecule. An additional polymerization join thousands of isoprene units together to form polyisoprene or natural rubber. How the coagulation of latex. The milky fluid obtained from tapered rubber trees is called latex. It consists of an aqueous suspension of colloidal rubber particles. Each rubber particles is made up of rubber polymers covered by a layer of protein membrane. Negative charges are found on the surface of the membrane, making each rubber particle negatively charged. The negatively charged rubber particles repel each other, preventing themselves from combining and coagulating. An acid such as methanoic acid or formic acid added to make the latex coagulate. Hydrogen ions from the acid neutralize the negative charges on the surface of the membrane. So, a neutral rubber particle is formed. When these neutral particles collide with each other, their outer membrane layers break up. The rubber polymers are set free. The rubber polymers start to coagulate by combining together to form large lumps of rubber polymers, which then precipitate out of the latex solution. Latex can still coagulate if acids are not added. Normally, the latex will coagulate if left overnight. Bacteria from the air slowly attack the protein on the membrane to produce lactic acid. Ionization of the lactic acid produces hydrogen ions. The hydrogen ions neutralize the negative charges to form neutral rubber particles, allowing coagulation to occur. However, alkalis such as ammonia solution are added to latex to prevent coagulation. The hydroxide ion from alkali neutralize hydrogen ions produced by lactic acid as a result of bacterial attack on protein. Because there are no hydrogen ions to neutralize the negative charges on the rubber particles, they remain negatively charged and hence cannot combine and coagulate. Vulcanization of rubber. Vulcanization is a manufacturing process discovered by Charles Goodyear to convert raw rubber into a tough, useful product. In this process, 1 to 3% by weight of sulfur is added to raw rubber and the mixture is heated carefully. Sulfur atoms form cross-link between adjacent chain of rubber polymer at the carbon-carbon double bond. The number of sulfur atoms in the cross-links is usually 1 to 4. Cross-linking improves the properties of raw rubber. It will make the vulcanized rubber, number one, a tougher material that is more resistant to oxidation. Number two, more elastic as the cross-link change can revert back to their original position. Number three, more heat resistant, which means the vulcanized rubber is less soft and sticky on warming. And number four, less soluble in organic solvent. Research on natural rubber in Malaysia. The rubber industry helps to bring in foreign exchange for the country. Important for the country to maintain and expand its research and development on rubber to ensure that rubber industry remains as a major revenue earners for Malaysia. The following institutions and research centers are entrusted with the role to further develop and expand the role of rubber in the Malaysian economy. RRIM, Rubber Research Institute of Malaysia. MRPRA, Malaysian Rubber Producer Research Association. Rubber Board of Malaysia, Rubber Technology Centre, and various local higher institutions of learning. What are the contribution of palm oil and natural rubber? Oil palm and rubber are two of the major agricultural crops in Malaysia. These two crops play a major role in the country's economy. Palm oil and rubber industries bring in foreign exchange for the country, help to develop and prosper many related industries such as automobile and food industries. Many jobs and careers are dependent on these two industries. Malaysia stays ahead and remains the world's major producer and exporter of palm oil and natural rubber.